Dear learners, welcome back to SWAYAM program on Information Technology Applications in Libraries. Today we are going to learn about IoT applications in libraries, Internet of Things in libraries. This is today's agenda. We will be covering the introduction part, then Internet of Things, what is a conceptual framework, evolution of IoT, major components of IoT, IoT architecture and the taxonomy, technology behind Internet of Things, development tools and open source framework for IoT implementation, application areas for IoT in libraries, examples of IoT based library services, advantages in IoT applications and challenges in IoT applications and libraries, and the future development of Internet of Things. These are the area which we are going to cover in this session. So, dear learners, Internet of Things refers to the interconnected network of physical devices that are embedded with software, sensors and connectivity. Learners, the Internet of Things refers to the interconnected network of physical devices that are embedded with software, sensors and connectivity, enabling them to exchange data seamlessly. This network facilitates communication between devices and allowing them to collect, share and analyze data across the vast systems. One of the key features of IoT is its ability to operate autonomously without requiring any human-to-human or human-to-computer interaction. By automating and streamlining process, IoT makes systems more efficient, reducing the need for manual intervention. In addition to improving operational efficiency, IoT enables advanced analysis and predictive capabilities, providing valuable insights that can enhance decision making. It also offers personalized and convenient solutions, adapting to individual users' needs and preferences. Through the creation of a smart environment, IoT supports innovations across various industries, organizations and libraries, deriving digital transformation and shaping the future of everyday life. As IoT continues to evolve, it promises to transform how we interact with the world around us, making it more connected, intelligent and responsive. Now we will discuss what are different applications areas of IoT libraries. Learners, now we will discuss about IoT conceptual framework. The following equations describe a simple conceptual framework of IoT. Physical object plus controller, sensor or actuators plus internet. Learners, now it is very interesting to identify what is a conceptual framework of IoT. The following equation describes a simple conceptual framework of IoT. Physical object, controller, sensor, actuators, internet equal to Internet of Things. So these are the major components you will find in the Internet of Things. There will be a physical object or device, then there will be a controller, sensor or actuators and internet. So the Internet of Things as consisting of an umbrella, a controller, a sensor and actuators and the internet for connectivity to a web service and a mobile service provider. Generally, IoT consists of an internet network of devices and physical objects wherein a number of objects can gather the data at remote locations and communicate to units managing, acquiring organizing and analyzing the data in the processes and services. Now it is interesting to identify what are the evolution of IoT. Now let us see what is the evolution of IoT. During the period now let us see what is the evolution of IoT. During the period 1969 to 1995, there is we are calling as the Internet of Boffins. This phase represents the early development of the Internet, primarily limited to researchers, academics, and government officials. The term boffins, the term boffins, the term boffins refers to scientists or experts. The key milestone in this period, we can say, development of ARPANET and the basic internet protocol like TCP/IP emerged during this period. Then, during the 95 to 2000, this 5 years is known as the Internet of Greeks. The Internet started to expand beyond researchers to early adopters and technical enthusiasts. This phase saw the creation of websites and the first wave of web browsers like Netscape. It was still technical in nature, requiring a higher level of knowledge for users to participate. It was not user friendly. So that period is known as the Internet of Greeks. And during 2000 to 2007, it is known as Internet of Masses. The Internet became mainstream. The Internet became mainstream, accessible to a broader audience. The key developments we find that the key developments of that period was the dot-com boom, rise of search engines, that is Google and social media platforms like MySpace, Facebook, etc. The e-commerce also flourished during the period of 2000 to 2007, and Amazon, eBay, Alibaba, so like that, e-commercial website become popular during this period. Another landmark development you will find in the period of 2000. Another landmark development you will find during the period of 2007 to 2011. That is known as the learners. Another landmark of development we witnessed during the period of 2007 to 2011, that is known as mobile internet. This phase marked the rise of mobile connectivity with the advent of smartphones and wireless technologies. The key milestone, we can say, the launch of iPhone in the year 2007, the proliferation of mobile applications and enhanced wireless network like 3G, 4G, etc. The internet became portable and personal during this period. And from 2012 onwards, we will be finding the Internet of Things. The Internet of Things evolved to a network of interconnected devices. Students, during the period of 2012 and later on, we find the development as a Internet of Things. The Internet evolved into a network of interconnected devices beyond traditional computers and phones. IoT involves smart devices communicating and sharing data autonomously. Example, smartphones, wearable industrial IoTs, etc. have been developed. This phase focuses on automation, big data, and real-time communication. This is something about the history of IoT. Learners, now let us discuss about the major components of IoT system. The major components of IoT devices are: one is a physical object, second is a communication module, and third one is a software. The physical object, that means with embedded software into a hardware. Hardware consists of a microcontroller, filmware. The major components of IoT devices are physical object, communication module, and the software. Physical object with embedded physical object with embedded software into a hardware. Hardware consists of a I repeat, physical object with embedded software and hardware. Hardware consisting of a microcontroller, firmware, sensors, controller unit. Hardware consists of a microcontroller, firmware, sensors, control unit, actuators, and communication module. In the communication module consists of that's a software consists of a device APIs and device interface for communication over the network and communication circuits or the ports, and the middleware for creating communication stacks using 6LoWPAN, COAP, LWM2M, IPv4, IPv6 and other protocols. Software for actions on messages, information and commands which devices receive and then output to the actuators. Software is used for actions on messages, information and commands which the devices receive and then output to the actuators. This software is used for actions on messages, information and commands which the devices receive and then output to the actuators, which enable actions such as glowing LEDs, robotic hand movement, etc. Now we are going to discuss on IoT architecture and taxonomy. Learners, now we are going to discuss on the IoT architecture and taxonomy. The IoT architecture, which consists of 5 layers: the perception layer, the transport layer, the processing layer, the application layer, and the business layer. The perception layer is a physical layer which has sensors for sensing and gathering information about the environment. It senses some physical parameters or identifies other smart objects in the environment. The next layer, that is the transport layer, transfers the sensor data from the perception layer to the processing layer and vice versa through networks such as wireless, 3G, 4G or LAN, Bluetooth, RFID and NFC. So the transport layer will be transferring the sensor data from the perception layer to the processing layer. In the processing layer, it is also known as the middleware layer. The processing layer is also known as the middleware layer. It stores, analyzes and processes huge amounts of data that comes from transport layer. It can manage and provide a diverse set of services to the lower layers. It employs many technologies such as databases, cloud computing, and big data processing modules. The application layer is responsible for delivering application-specific services to the users. It defines various applications in which the Internet of Things can be deployed. For example, smart homes, smart cities, smart health, etc. Then last layer, the business layer, that manages the whole IoT system, including applications, business and profit model and user privacy. These are the major architecture of Internet of Things. Now let us see what is technology behind IoT. What are different technologies required to develop an IoT? There is required an hardware, that is a Arduino, Raspberry Pi or Intel Galileo or Intel Edison, ARM Mbed, Bosch SDK 110, BeagleBone Black and wireless SoC. This type of hardware is required to develop a IoT. And another is Another technology required is Integrated Development Environment, IDE, for developing device, software, firmware, and APIs. And we record some protocols like RPL, COP, RESTful, HTTP, MQTT, XMPP, that means extendable MQTT, XMPP, extensible messaging and presence protocol. Then third technology required in the field of communication. We need a power LAN Ethernet, RFID, NFC, 6LoWPAN, UWB, Zigbee, Bluetooth, Wi-Fi, WiMAX, 3G, 4G, 5G, etc. That is for required for communication. And as a network backbone, we need IPv4, IPv6, UDP, and 6LoWPAN. And the software part, we record Riot OS, Contiki OS, ThinkSquare, Mist firmware, Eclipse IoT. Then for internet work, we need a cloud platforms like Data Center, Sense, ThinkBox, Nimbits, XYLE, OpenHub, AWS, Amazon Web Service. The internet work include cloud platforms like Data Center. We need some companies, some data crowding centers like Sense, ThinkVerse. Internet work, we record a cloud platform for that and a data center. Cloud platforms like Sense, ThinkWorks, Nimbits, Xavili, OpenHub, Amazon Web Service, IoT, IBM Bluemix, Cisco IoT, 10x and Fog, everything Azure, TCS, CUP, etc. can be used as a cloud platforms. For machine learning and algorithm and software, you need an example of a machine learning software like Grok from Numenda Incorporation. Such type of things are required to develop a IoT in our organizations. Next, let us check the development tools and open source framework for IoT implementation. We need some open source framework like Eclipse IoT that provides open source implementation of standards such as MQTT, COP, OMA-DM, OMA-LWM-2M, and tools for working with Lua services and framework that enable an open Internet of Things. Arduino development tools provide a set of software that includes an IDE and the Arduino programming language for a hardware specification for interactive electronics that can sense and control more of the physical world. Kinoma software platform, Kinoma Create, kit for prototyping, Kinoma Studio development environment, and Kinoma platform runtime are three different open source projects. Kinoma Connect is a free application for iOS and Android smartphones and tablets with IoT devices. Now let us discuss what are the applications of IoT in our libraries. We can use IoT for communication handling. IoT enabled communication system can be used for real-time notification about book availability, overdue books, or upcoming library events. It can also facilitate communication between staff and library users. IoT can be used for staff management. IoT sensors can track staff movements to optimize staffing levels and help the task management. For example, the restocking books, providing assistance to patrons, etc. Automated systems can help schedule shift and monitor work efficiency in a very easy manner. And IoT can be used for library resource management, like RFID and IoT sensors can track the availability and the location of books in the library. Automatic recording systems for books and materials can ensure resources are always available for patrons. IoT can be used for storage management and space optimization. IoT can optimize space utilization by monitoring and managing the arrangement of physical resources. Library influence analysis. IoT devices can collect data on library usage patterns, like footprints, book borrowing trends, and similar methods to assess the effectiveness of services. This data can be used for improving library programs and outreach activities. Another important aspect is library data analytics. Data from IoT sensors can be analyzed to understand peak usage times, popular resources, and user preferences. This information can be optimized library services, improve inventory management, and personalize user experiences. And IoT can also be used for decision making. IoT-enabled data analytics can help library managers to mark strategic decisions. Library decision making. IoT-enabled data analytics can help library managers to make strategic decisions, such as identifying resource gaps, planning budget allocations, and improving user experiences based on data-driven insights. It can also be used for environmental monitoring. Sensors monitor temperature, humidity, and air quality to preserve sensitive materials, and supports energy conservation, and it ensures a comfortable atmosphere for patrons. Security and surveillance. IoT-enabled cameras and sensors monitor library access points, enhances safety of users, staff, and the valuable assets. Now let us discuss what are the examples of IoT-based library services. You'll see some best practices libraries being used IoT while providing the services to their users. You'll find very many libraries are using the IoT for resource tracking, membership applications, location tracing, notifications, research facility, smart reference services, and self-service. So let us see let us see how these libraries are using, what type of products they are using for providing this IoT-based services to its clientele. Resource tracking. Resource tracking means it is LIoT-enabled library services track resources and guide users to correct locations using sensor broadcast. Some examples, we see the Mansueto Library, University of Chicago, USA, uses robotic cranes to retrieve documents in under 3 minutes from an underground automated storage system of the library. And another example, you can see the Santa Clara University Library. They use automated retrieval system ARS to employ 3 robotic cranes to fetch items from metal bins electronically. So these 3 robotic cranes, they will collect their books from various storage places, stacks, to its users. National Library Board Singapore. Robotic technology assists users in locating books on shelves. You'll find the picture of Mansueto Library, University of Chicago, USA. You will find there are no people under this underground where the books are stored. Only the robots, they rule there. When a reader orders a book, the system sends a robot to extract the stack to deliver the book, and it will bring to the upstairs. Then the step tools and smart chairs you'll find in the picture that will direct you, this IoT-based device, that will direct you to the location of the book wherever it is available in the stack. You'll find the membership app. There is some libraries using the IoT for membership applications that totally replace the physical membership cards, and this membership cards are membership cards replaced by smartphone applications, and it enables seamless library entry without carrying a physical cards. And they have the real-time book tracking system. Members can track the availability of books in real time through the applications. Sensor-based identification systems, also some libraries are using it. To face recognition and biometrical identification system can be introduced to eliminate the need of carry membership cards and simplify user access to library services. IoT-based member identification system is also available, where the records library footfall, and this IoT-based identification system will record library footfall and section-specific user visits. It provides data for analyzing user engagement and the preferences. The Taipei City Public Library, you will find all these features. The Taipei City Public Library, you will find such applications. Next is location tracing. The sensor-based indoor navigation is available. There the users enables users to locate specific sections or document in a stack areas. It overcomes the limitation of GPS in indoor spaces. For example, the BLIP, the Bluetooth-enabled indoor navigation techniques that was introduced by Uttarwar and Chong. That guidelines used to guide users. BLIP Bluetooth-enabled indoor navigation techniques was introduced by Uttarwar and Chong in the year 2017. That guides users to specific tracks using proximity sensors without human intervention. For example, this was implemented in Auckland University of Technology Library, New Zealand. And the notification also possible. The LIoT-enabled libraries architecture provides alerts for new arrivals, news, events, workshops, seminars, and conferences. The information will be provided to the users. Newly published articles of interest. The examples we see the Blue Cloud mobile applications that connect users with the libraries anytime, anywhere through smartphones. Iguana mobile library applications at Dorwell Library and Niagara Falls Public Library. Capira mobile technology by OCLC that facilitates user interaction with the library networks via smartphones. Research facility, smart collaboration platforms are there. That will be help researchers find collaborators in the same or interdisciplinary field. And it also operates under the unified network to promote interaction. Next, we can say that IoT is also being used for enhancing the research facilities of the libraries. As far as research facility is concerned, we have the smart collaboration platforms. This will be helping the researchers to find collaborators in the same or interdisciplinary fields. It operates under the unified network to promote interaction and resource sharing. For example, IBACO technology for collaborations used by Orange Country Library System to transmit location-based Bluetooth signals. It guides researchers to shared resources, enhancing opportunities for sharing research ideas, building collaborative networks. Smart citation technology that measures the quality and authenticity of citations as rated by fellow researchers. And it also sends notification to the target audience. And we have the smart reference service. Robot reference services is being provided by using artificial intelligence and machine learning, and it is available 24/7. And features of LIoT-based chatbots. The chatbots encrypts and utilize users' previous query behavior for personalized responses. It handles diverse user requirements, including suggesting preferred documents and events, confirming items availability or suggesting substitute via robot-mediated responses. University of Technology, Sydney, UTS library is being used such type of. The University Technology, Sydney, UTS library is being used as such a type of smart reference service. And for self-service user-controlled library facilities like similar to smart home technology, users actively participate in managing library appliances, and it can control via smartphones applications, illumination and brightness of lights, temperature and humidity regulations, brightness of projectors, screens, and volume tuning control can be done by the user himself. Sensor-based automation, University of Helsinki Library, they use this light sensors automatically adjust. University of Helsinki Library uses light sensors automatically adjust lighting based on user activity and natural light availability. The air quality sensors optimize air circulation and quality inside the library. Denmark's Tekniske Universitet Library, their air width sensors measures humidity, temperature, and the level of carbon dioxide, across library zones. The major advantages of IoT applications include improved safety and security, resource optimization, space optimization, enhanced user experience, efficient facility management, reduced staff requirement, automated library management, and time saving and improving the efficiency of the library. Now let us discuss challenges in IoT applications. Negative perceptions. Information professionals and technologists may have concern about IoT integration libraries. Declining use of library resources. IoT adoption may not immediately address the declining trend in the usage of traditional library resources. Staff training. Staff need proper training to efficiently use of IoT technology. User awareness. There is a need to create awareness among library users about the IoT-based services. And some technical issues libraries may face. Technical difficulties in implementing and maintaining IoT systems. And another important challenge is the financial constraints. The transition to IoT systems involves substantial financial cost, especially in upgrading infrastructure. And there is a risk of security risk, and there is a security risk, malware and data theft will be, we have to take care of it. And the infrastructure requirements, IoT implementation requires reliable hardware, software and internet networks, which may be unavailable during emergencies like accidents or disasters. The future of IoT, smart libraries. IoT may transform library buildings into small environments where patrons can interact with various objects and access information via communication-enabled devices. So this is one of the important feature we can say. IoT may transform library buildings into smart environments. And another important point is enhanced library services. IoT could revolutionize library functions and services, making them more user-friendly and efficient. And deep integration. IoT could expand into deeper areas of library operations, providing detailed statistics on resources usage, areas with most activity, user satisfaction, and identifying when users get frustrated with the library resources. User experience insights. IoT can offer insights on user fluctuations levels and patterns, such as when users turn to Google instead of library resources, then we can find the user is not much interested, he is frustrated. Next is user experience insights. IoT can offer insights on user frustration levels. Next is user experience insights. IoT can offer insights on user frustration levels and patterns, such as when users turn to Google or any other websites instead of library resources. That means the user is not interested in the reading the library sources at that time. He is not in a good mood. So we can identify the frustration level of the users. Dear learners, let us conclude that the Internet of Things hold. Dear learners, let us conclude that the Internet of Things holds significant promise for libraries, offering opportunity to enhance resources and services. If implemented thoughtfully, IoT can add substantial value by improving library operations and user experiences. However, since IoT is still evolving, it makes sense for libraries to stay informed and wait for technology to become more widely accepted and refined before the full-scale implementation. At the same time, libraries can benefit from observing the experiences of early adopters, learning from their successes and challenges, and finding ways to optimize the use of IoT in library settings. Libraries have always been adaptable to change, as seen throughout the history. and IoT is poised to be the next transformative force, much like the internet was. As IoT advances, it promises to revolutionize. Libraries have always been adaptable to change, as seen throughout the history. And IoT is poised to be the next transformative force, much like the internet was. As IoT advances, it promises to revolutionize the way libraries interact with their patrons, leading to a multitude of changes in library operations and services. I would like to thank the authors of different information sources, illustrators. I thank authors of different information sources, illustrations, as well as the creators of various websites, which I consulted or used for preparation of this lecture to help learners to understand the concept more clearly. These are the references being used. So now I take this opportunity to thank all my learners for listening it very carefully, and we will be meeting with another lecture in the next class. Thank you very much. Take care.